Okay, we're going to talk about how to find the domain of rational functions. So these are functions that look like a fraction. And the reason we have to talk separately about finding the domain for rational functions is that there will be things we need to leave out of the domain. And the reason for that is one of the biggest rules in math is that you can never divide by zero. Okay, so you can never divide by zero, which means anything that makes the denominator equal to zero cannot be in our domain. For example, let's look at this first one. F of x equals 1 over x plus 3. What would happen if we try to plug in negative 3? We would get 1 over negative 3 plus 3, which would give us 1 over 0. 1 divided by 0. That can't happen. We don't even want to think about it. That's really bad. So this is actually undefined. If you think about the function being like a machine, negative 3 is something that breaks our machine. So we have to leave out negative 3. Okay? And so our domain would be everything except negative 3. Negative 3 is the only thing that's going to make our denominator 0. So we would go from negative infinity to negative 3, union negative 3 to infinity. So if you want to think this, write out the steps of finding the domain of a rational function, you're going to set the denominator, which is the bottom, equal to 0, and you'll solve for x. And then those are the values that you leave out of the domain. So we'll say those values are not in the domain. Okay, so here we have g of x equals 1 over x squared minus 16. So we'll take x squared minus 16 equal to 0. And x squared minus 16 is actually a difference of squares. It factors as x minus 4 and x plus 4. So if we set each of those factors equal to 0, we'd have x minus 4 equals 0 and x plus 4 equals 0, which means x is equal to 4, x is equal to negative 4. So we have to leave negative 4 and 4 out of our domain. So our domain, so think about leaving the least one out first. So first we'll think about leaving out negative 4. We'll go negative infinity up to negative 4, union negative 4 up to the next value. We need to leave out 4, union 4 to infinity. So that's how we would write out all values but leaving out negative 4 and 4. Now notice it didn't matter what the domains of these functions, or the numerator, the top of these fractions were at all. The fact that they were ones didn't matter. We could have anything up there and it wouldn't have changed. When we're finding the domains of rational functions, what we care about are what makes the denominator 0, and that's what we have to leave out.